All right, I'm going to pick up here on number 17, right down here. There we go. I'll use the figure at the right for exercise 7 through 19, write each ratio. So the first one is sine of angle B. So I'm going to mark my angle. I've got my opposite side. Remember our phrase for trig, so ka, toa. So sine tells me my opposite side and my hypotenuse. So sine of B is going to equal 24 over 26. Now I've got cosine of B, that's going to be my adjacent side, 10 over my hypotenuse, 26. Now you have to be careful on this last one of tangent because they're going to change the angle to A. So this is the angle I'm talking about now, which changes this one to opposite and this one here to adjacent. And tangent is O over A, so I go 10 over 24. Okay, so now I look at the next one. This is just going to be solving trig problems here on this next section, 20 through 24. So on the first one, once again, I'm marking my angle. I'm labeling my sides. I've got opposite and adjacent. That's once again TOA for tangent, so I go tangent. I ask myself if it's tangent or tangent inverse. I know it's regular tangent because I have the angle measure and I can put that in my parentheses. Now it equals the opposite value over the adjacent value. So now I have to get rid of that 20. I multiply both sides by 20, it cancels. And now I have 20 times tangent of 40. I type that up in my calculator. Let's see what that gets me. And I should end up with x being equal to 16.8. Length to the nearest tenth, angles to the nearest degree, and that's a length, so that looks good. Next one, I've got my angle x here. I'm going to label my parts. I've got opposite, hypotenuse, adjacent. Although there's nothing on the opposite side, so I'm going to scribble that out, which tells me I'm going to be using co for cosine. So I go cosine, and now I pause to think. Cosine or cosine inverse. This one will be inverse because I'm looking for x. I go inverse, and it's cos, so it's adjacent over hypotenuse. And now I type that up. And it looks like I am getting for x, and I'm rounding to the nearest degree because this is an angle, 23 degrees. Okay, now I take a look at the next row. Here I've got an angle of 48 degrees. Across one I have opposite. Then I have hypotenuse, and then I have adjacent. There's nothing on the hypotenuse, so it looks like I'm using O and A again for another tangent. Now I did know that angle measure. It is 48 degrees, so it's a regular tangent, and it's going to equal my opposite value over my adjacent value. So I'm going to multiply both sides by 5, and now I go 5 tangent of 48, and it looks like my x value in this case is 5.6. Taking a look at the next one, I'm marking my angle, I'm labeling my parts, opposite, hypotenuse, adjacent, nothing on the adjacent, so I'm not using it. O and H is sine. This time I'm looking for my angle measure, so it's sine inverse. It's the opposite side over the hypotenuse side because of so. And then I go to my calculator, and I should end up, oops. There we go. It helps if I type it in correctly. I should end up with x being equal to 29 degrees. Okay, on this next one here, I've got my angle of 54. I've got x opposite it, my hypotenuse. Nothing's there. I've got 8 on my adjacent. I know the angles, so I'm going to use a regular trig function. It looks like I'm going to use tangent because I have an opposite and adjacent. I'm going to go plug in that angle measure of 54 degrees. It equals the opposite side over the adjacent side, and I'm going to type that up. And I get x equal to 11.0. Alright, so that's your basic trig. After that, we had lesson 8.4 where we started to talk about angles of elevation and depression. So this picture should look familiar. We're just going to quick describe each one of these angles as elevation or depression, and then from what to what. So first off, I've got a little bird up here, so I'm going to refer to that. I've got a balloon over here and the ground. So if you remember, an angle of elevation is made with a horizontal line looking up, and an angle of depression angle of depression is made with a horizontal line looking down. So here I have a horizontal line at angle 1, and I can see it's going down. So I would say angle of depression, and then it's going from the bird to balloon. So I'd say from bird to balloon. So now if I'm looking at the next one, angle 2, I can see it's made with a horizontal line and it's looking up. That means it's an angle of elevation, and it's from balloon to bird. Running out of space here, so I'm writing a little cramp, trying to color code it to help you. Now I've got angle 3, horizontal line looking down. That's an angle of depression, and it's from balloon to ground. And last but not least, I get angle 4, horizontal line looking up. That's an angle of elevation from ground to balloon. And now I've got that one. So once we had a good establishment of that, we then took these ideas of elevation and depression and we started doing some trig word problems. That's this next part. So here it says an architect includes wheelchair ramps in her plans for the entrance to a new museum. She wants the angle that the ramp makes with the level ground to measure 4 degrees. Will the dimensions shown in the figure work? If not, what change should she make? So it looks like she already has a working ramp, or at least a diagram for it, and she just wants to make sure that it's going to meet her criteria. So if we think about if she's checking to see what that measure of the angle is, she wants it to be 4 degrees or less, we're going to find it. So here's our ground, here's our ramp, so our angle is going to be right here. So our goal right now is to find that angle. So I'm going to label my parts. I've got opposite, hypotenuse, and adjacent. Nothing on the hypotenuse, I just got O and A, which means I'm going to use tangent. Alright, it's an angle, so I use tangent inverse. It's my opposite side over my adjacent side. And I'm going to go check that out. So I go tangent inverse of 8 over 100, and I'm getting a fairly small angle. I'm getting x equal to 4.6 degrees. Now, her goal is that the angle is 4 degrees. Is this one currently 4 degrees? No. So will the dimensions in the figure work? No. If not, and it is a not, what change should she make? So if we're thinking about a ramp, there's a few things we can't change. We cannot change the height of the ramp. If we change the height of the ramp, we're changing the height of the building, which is way more complicated than we want to go into. So what we do need to change somehow is this length of the ramp. Now if I think about this, I have to decide if making it shorter will work or making it longer will work. You could try a few different numbers, see what happens if you try tangent inverse of 8 over 90, see if I change that base to that. And when I do that, I get an even bigger angle of 5 degrees. So what I would then want to do is take that base and make it longer. So I would say, no, the base should be longer. And we could even check how long it should be by seeing what we would get if we put a 4 degree in here for trig. Say we didn't know the base. We are searching for it. If we did tangent of 4 equals the opposite over the adjacent, what we would end up getting in this case then for the base of this ramp is actually 114 feet. So no, the base should be longer. If I want to be exact, it must be longer than 114.4 feet in order for it to have that 4 degree angle. And that's actually a question that they ask because when you're in a wheelchair, you can only, it's hard to go up steep inclines, and so they try to keep them kind of a low incline on those ramps. So this next one, a couple is taking a balloon ride. After 25 minutes aloft, they measure the angle of depression from the balloon to its launch place as 16 degrees. They are 180 feet above the ground. Find the distance from the balloon to its launch place. So we're going to just quick sketch a picture of this. Here's going to be my balloon, my hot air balloon. I'm not an artist. That's my hot air balloon. And says after 25 minutes aloft, they measure the angle of depression So depression tells you I'm going to have an angle like this coming down at 16 degrees. Okay. And then they are 180 feet above the ground. So, to its launch place, this would be where they're launching from. So this kind of makes this nice little triangle. So this distance also is going to be 180 feet. If this left side's 180 feet, so is this right side, so I can bring that over. The question is, how far are they from its launch place? So I'd put my X probably right here and solve from this triangle that I'm given. So I've got an angle, I've got an opposite side, I've got a hypotenuse side, that's a sine. So when I go sine of 16 equals opposite over hypotenuse. I'm going to type that up. And it looks like they are 653.0 feet away from their initial launch place. So now we're going to try another one. With all these word problems, the key really is in the picture that you set up. So we've got a surveyor who is 300 feet from the base of an apartment building. So here's my apartment building. He's going to be 300 feet away. Okay, so this is going to be my little surveyor. The angle of elevation to the top of the building is 24 degrees, and her angle measuring device is 5 feet above the ground. Since her device is 5 feet above the ground, that tells me that the angle is not going to start at her feet down here, but at this top right here. So I'm going to take that angle of elevation, go up from there. Now right now what I kind of have inside here is a trapezoid. So I want to take it and I want to split it up. So I have a triangle and a rectangle like that. And now my angle of elevation is going to be that diagonal and horizontal line. So that's where my 24 degrees is going to go. It says find the height of the building. So this is going to be a two-parter. We can use this trig in this triangle right here because we're going to have a right angle there to find our x value. And then once we do that, we're going to have to do a little extra because remember, her device is 5 feet above the ground. So I'm going to just set up my trig. If it's 300 feet down there, it's 300 feet up there. I've got an opposite side, an adjacent side. That's tangent of 24 equals opposite over adjacent. This one's going to be pretty nice to set up in my calculator. And it looks like I'm getting 133.6 feet. Now, that's not the actual height of my building if I'm looking. That's just this blue line. So what I need to think about is what is this red line? Because together they make the whole height. Well, I'm told the measuring device is 5 feet above the ground. So this here would have been 5 feet, which I can bring over to here as well. So what I want to do then is take this and add 5 to it. And then I end up with 138.6 feet for the actual height of my building. Okay. Now these next two problems here, we don't have many left, but their pictures are not necessarily accurate. So know that their pictures can kind of be confusing. Pay attention to the angles and such. It says find the missing sides, keep answers in simplest radical form. So no decimals on this chunk. All right, I see two triangles. In the first triangle, I have one side of 14 and one unknown side, and no angles. That's not enough information to do anything with. And the second triangle, I see I have a 6 and a 12 and an unknown side here. Having two sides of the triangle allows me to do something with that. And then if I get this side where the blue and the green overlap, I would have a side in the green triangle as well, which I could then use to find the x. Now because I don't have any angle measures, what I would use to figure this out is actually my Pythagorean theorem. My a squared plus b squared equals c squared. So if I look at the blue triangle, I know that 12 is my c value, 6 is going to be either my a or my b value, and then let's put in a y there for that unknown value. And I'm going to solve that. So I start to simplify. I'm showing my work as I go because remember, we're going to have to put this in simplest radical form. I get 108. Okay, now I know I have to take the square root, and since it's in simplest radical form, I'm going to have to simplify that. So I kind of use my knowledge of perfect squares to think about what going into that. It does end in an 8, which means it's highly likely that 4 does. So I'm going to quick check that. Yeah, it does. but also 1 plus 0 plus 8 makes 9, and I know that means 9's a multiple of it. So I'm just going to double check that. It is. And so rather than kind of splitting that up, if 9 and 4 both go into it, that means 9 times 4 does. And 9 times 4 is 36. So I'm going to assume that 36 can go into it. And now why I like that is because 36 is a perfect square. And I just checked and it looks like 36 times 3 makes 108. Now I split that up and I get y equals the square root of 36 times the square root of 3. I know the square root of 36 is 6, so I get 6 root 3 for that middle value there. Now I'm ready to use the Pythagorean theorem on the green triangle to solve, so I set it up again. A squared plus b squared equals c squared. My c is my 14 value. My a squared, let's call it x, and my b, let's call it 6 root 3. Here's where you have to be careful. Anytime you have a number like this with a square root and a non-square root, you want to put it in parentheses because you need to square the whole number. Okay, so we're going to pay attention to that as we go. So I checked 14 squared, and that's 196. Now, when I square this 6 root 3, I'm really going to take that square and distribute it to both numbers. So it's going to be 6 squared, which I know is 36, times the square root of 3 squared. Now, the square root of 3 squared, when I square root and square it, they cancel, and I'm left with the number inside, which is a 3. So I have a 36 times 3 there, which is 108. So I get x squared plus 108 equals 196. And now I just keep going. X squared equals 88. Now I need to keep simplifying, so I take my square root, and I just start to think about numbers that go into 88. It ends in an 8, so I would guess that 4 goes into it. It does, and 4 happens to go into it 22 times, so I go 4 times 22. I stopped after checking 4 because I was left over with that 22, and I know that no perfect squares go into 22. Okay, so now I split this up, square root of 4 times square root of 22, and I get x equal to 2 root 22. And that was the solution that I was looking for.